Section 8.4 deals with rational expressions. So you are going to have to flip your notes packet several pages, find section 8.4. Our objectives today, we are going to simplify rational expressions. We're also going to look at multiplying and dividing them. And then we'll spend the next couple days on the adding and subtracting. All right. A rational expression is the quotient of two polynomials. A rational expression is the quotient of two polynomials. That means you're setting up a ratio, all right, and you're going to have polynomial divided by a polynomial. It says we can use much of what we already know about multiplying and dividing fractions to do the same with multiplying and dividing rational expressions. It's just an algebraic fraction. We do want to always put it in simplest form. And simplest form is when the numerator and denominator have no common divisors. There's nothing that could be divided out of both of them. Okay? So there's some samples here of things that are simplified and others that aren't. We're going to start with the ones that aren't. Looking at this one. X divided by x squared. What's something that we could have reduced out of that? An x, right? We could have taken an x out of the numerator and denominator. For the second example, there's an x minus 3 that's common to both. That could have been reduced out. The third example is a little harder to tell because it's not in its factored form, but they do have a common factor. I do want to caution you about the most common mistake that students make. And that is when you see a trinomial like this divided by a trinomial, a lot of students want to do things like that and say, I'm just going to get rid of those x squareds, or I can reduce 6 and 2. You can't do that. What you're doing there is you're subtracting off a term. You can't take off terms. You can only take off common factors. Okay? It would be like me saying, take 2 plus 7 and divide it by 2, and you saying, well, I can just divide out those two 2's and I just get 7 for an answer. Do we get 7 for an answer? No. All right, so you can't take x squared over x squared and say, I'm just going to reduce that out. It doesn't work. But we can do things where we factor both this numerator and this denominator and then look for common factors. Does that make sense? Okay. So that's going to be our first step. We are going to factor. Make sure you put a note of that before the simplifying section. We always want to factor everything to look for those common things that we can take out. All right. The second step, once we get everything factored, is to look for any domain restrictions. And we do have restrictions on the domain because a rational expression has a denominator. Denominators can't be what? 0. So I would have to look and see, is there anything that's going to make those denominators 0? So let's look at our first example up here. That's how it's going to be given to you. Your first step is to factor it. So now it looks like this. Okay? Your very next thing should be to look at those denominators and say, what can x not be? And in this example, x cannot be what? What makes the first factor a 0? 1. So x can't be 1. It also can't be a negative 2. Our next step is to reduce out the common factors. So now I would say, well, there's an x plus 2 and an x plus 2. I can reduce those out. My simplified answer is x minus 3 divided by x minus 1. Make sure that you list these domain restrictions before you start crossing stuff out, because some of them tend to disappear when you look at your final answer. In other words, if I just look at my final answer, I don't see that x can't be negative 2. But it is a restriction I have to consider. All right? So you always list them before you start crossing and simplifying things out. All right. Take a second and factor both the numerator and denominator. All right, what do we get for the numerator pieces? X plus 5 is one of them. What's the other one? X plus 2, okay? Denominator. Somebody else. Okay, I heard a minus 5. What else? A plus 2? Okay. We factored it, step 1. Step 2, domain restrictions. What can X not be? From the first one, it can't be a 5, and from this one, it can't be negative 2. Doesn't really matter what order you write those in, okay? But you want to list both of them. Now, I put them over on the side because they are part of my final answer, okay? Now I look through and say, for step 3, do I have any factors that match? Do we? We need one in the numerator, one in the denominator. So they both have an x plus 2 factor. We can divide that out of both. My simplified answer then would be x plus 5 divided by x minus 5 with this domain restriction listed. Okay? In that example, we started out with a trinomial divided by a trinomial, right? 3 terms divided by 3 terms. How is this next one different? We really don't have any factoring. It's already in its factored form, right? It's a monomial divided by a monomial. So we can go right to looking at domain restrictions. In this case, we have 2 variables. Both of them have a restriction. What can X not be? We're just looking at the denominator. What would X be that would be a problem? 0? If X was 0, we'd have a problem, right? The whole denominator would become 0. How about for Y? Y can't be 0, same reason. Okay. What can we do with the 24 and the negative 6? Can we reduce that? Becomes what? Negative 4, okay? Looking at our x's. If we have 3 x's multiplied together on top and 2 on the bottom, what do we have left over? 1 on top, okay? And for the y's, we have an extra 1 in the denominator, yep. So that would be my simplified answer. All right, you guys go ahead and do part B here. All right, let's check the second one. Factors for the numerator should be x plus 4 and x minus 2. How about the denominator? X minus 3, x minus 2. Okay, so domain restrictions. X can't be 3 and 2? 2 and 3? All right. And then what can we reduce? X minus 2's. So final answer would be x plus 4 divided by x minus 3. Okay. Now, the third one has something a little different with it. Let's look at the denominator first. How do you factor x squared minus 9? Okay. Now the numerator, there's 2 options. What's one thing I could factor out of that? I could take a 4 out. What's another option?
Negative 4.
I could take a negative 4. And when I first look at it, I don't really know which one's going to be most helpful. Okay? So most common thing is students would take a 4 out. If I take a 4 out, what's left? Oh, this is not working today, is it? All right. We'd have 3 minus x if we pull a 4 out. All right, we've got x plus 3x minus 3 on the bottom. Is there anything that drops out? We don't have things that match. We don't have factors that match. The 3 minus x in the numerator and the x minus 3 in the denominator aren't identical. But they are what? In the top, the 3 is positive. In the bottom, it's negative. In the top, the x is negative, but the bottom's positive. What do we call positive and negatives? 5, negative 5, 2, negative 2. Opposites. Those are opposite factors. What happens when we take 5 and divide it by a negative 5? We get negative 1. What happens when we take 10 divided by negative 10? We get negative 1. If we take a factor and divide it by its opposite, we do get a negative 1. So I can technically reduce these out, but it leaves me a negative 1 somewhere. Typically, we put it in the numerator. So my final answer is going to end up being negative 4 divided by x plus 3. Okay? Now, earlier we said another option would have been to take out a negative 4 right away. If I had pulled a negative 4 out, that would have left me a negative 3 plus x in the numerator. And negative 3 plus x is equivalent to x minus 3. Those would have dropped out right away. Does that make sense? So either option is fine with me. Just be careful you don't forget to reduce out opposites. All right. What were the domain restrictions for that one? X can't be positive or negative 3? Okay. All right, shifting from simplifying to multiplying. The only thing different here is that we have 2 of everything. We have 2 numerators, 2 denominators. You're still going to go through the same 3 steps. Factor everything, look at domain restrictions, and then reduce out common factors. Okay, so how would this first one factor? X squared plus x minus 6. X plus 3 and x minus 2. Okay, denominator is x minus 5. How does x squared minus 25 factor? All right, denominator x plus 3, somebody else? X plus 1. Okay. So we have all of our, that's an x. We have all of our factors. What are my domain restrictions? I have to look at any denominators. X can't be a 5, negative 3, or negative 1. Yes? All right. Now, when we go to reduce things, we need one piece from the numerator matching one piece in the denominator. They can be straight up and down on top of each other, or they can be diagonal. So what can we get rid of? X plus 3's. What else? An x minus 5. All right. So my answer will be x minus 2 times x plus 5 divided by x plus 1. Looks like I have to redo my board again. If this wasn't a multiple choice question and that wasn't one of your options, you could multiply the tops, right? FOIL them out and find the answer that way. For our class, we're just going to leave it in its factored form like that. Okay? All right. You guys go ahead and try the next one. I'm going to redo my board. All right. Numerator, we can take out a 2. We have x minus 4 left. Denominator factors into x plus 4 and x minus 4. Numerator, x plus 4 and x plus 1. Denominator, x plus 4 times x plus 4. Does that match what you have? All right. What can x not equal? All right. Now, common things we can take out. What do you see? X minus 4s. Okay. What else? X plus 4s. Now, there's a whole bunch of x plus 4s in the denominator, right? I could have taken any one of those, but I can only do a 1-to-1 cancellation. I can't take one on the top and all 3 on the bottom. So what we have left, we have a 2, we have an x plus 1 for the numerator. Denominator, we have an x plus 4 squared. I think this is the best my board will get today, so we're just going to have to put up with it. All right. For division, we have an extra step that instead of dividing fractions, we typically multiply by reciprocal. Okay? So we are going to have to flip that second fraction. We're going to go ahead and factor it as we flip it. Okay? So for the first fraction, we have a 2 minus x for the numerator. Denominator, we get x plus 1 times x plus 1. Okay? Now, instead of dividing, we're going to multiply. We're going to flip this. So the x squared minus 1 becomes the numerator. We're going to get an x plus 1 and an x minus 1. The numerator then turns into the denominator. And x squared plus 3x minus 10. We already did this one today. We get x plus 5 and x minus 2. Okay, here's where you have to be a little more careful. Because when you list your domain restrictions, we said they come from numbers that would make the denominator 0, right? We actually have 3 different places that were denominators. This part right here, right? That's a denominator. This part right here is a denominator. This was originally a denominator. So we flipped it so that instead of dividing we could multiply, but it still counts as a denominator in the question. We still have to worry about domain restrictions for it. So you're actually going to look at all 3 of those parts. Okay? What can x not be in this first denominator? Can't be a -1. Okay? Can't be -5. It can't be a 2. And then from this top piece, it also can't be a +1. Okay? We already have the -1 listed. What can we reduce out? There's an x plus 1 there with that. What else? Yeah, x minus 2 and 2 minus x are what? They're opposites. So I can reduce that out, but it's going to leave me a -1. All right? So I end up with a -1 times x minus 1 for the numerator and an x plus 1 and an x plus 5 for the denominator. Questions on that? All right, you guys go ahead and try the next one. All right, numerator, we should have x plus 4 and x plus 1. Denominator, we should have x plus 4, x minus 3. We're multiplying, so we're going to flip it over. We take a 2x out of the numerator. We get x minus 3. It's just going to be one of those days. Denominator, the x squared minus 1 becomes x plus 1, x minus 1. Yes? Okay. So restrictions. What can x not be? -4, 3, plus or minus 1, and 0. Everybody get the 0 from the top? Okay. Canceling out common ones. We've got x plus 4s. I see an x minus 3. I see x plus 1s. So my simplified answer would be 2x divided by x minus 1. Okay. Questions on multiplying, dividing, or just basic simplifying? All right, the last one that we're going to look at gives you an example of where you might see division of rational expressions. Okay? It says your community is building a park. It wants to fence in a play space for toddlers. It wants the maximum area for a given amount of fencing. Which shape, a square or a circle, provides a more efficient use of fencing? So let's say we have a set number of feet of fencing that we can use. The question is it better to make a circle out of it or a square? One measure of efficiency is to look at the ratio of the area that you can fence to the perimeter, or the amount of fencing that you would need. So we're going to always compare area to perimeter. I've given you the formulas for both the squares and the circles. Do those look familiar? Okay, now we have one little problem when we're trying to compare these, and that is with a square we use an S for side length, but in a circle we use an R for radius. So we're going to have trouble comparing them if one is in terms of S and one is in terms of R. So we need to compare them where we have a common variable. So what we're going to do is we're going to take both the perimeter formulas and we're going to solve for S and R. Okay, so that's my first step. I'm going to take perimeter here. Perimeter equals 4S. If I want to solve for S, I'm going to get perimeter divided by 4. Okay. For the circle, I'm going to do the same thing. I'm going to take that perimeter formula, which is really our circumference formula. If the perimeter equals 2 pi r, we can solve for r by taking perimeter divided by 2 pi. Okay? All right. The next thing we're going to do is we're going to compare the ratios of area to perimeter. We're going to keep using P for perimeter because that's the one that I can get to be common. So for a square, area to perimeter would be side squared divided by P. You're going to have to just interpret what I'm saying. Side squared divided by P. Okay. For circles, our area to perimeter ratio would be pi r squared compared to P. Okay. The next step is to substitute that expression we came up with for S and R so that we can get those S's and R's out of our ratio. So I'm going to take this, S equaling P divided by 4, and I'm going to replace S with that. So I'm going to get S squared, which we said is P divided by 4, squared divided by P. Okay, I just replaced S with P divided by 4. On this one, I'm going to replace R, so I have pi times R squared and R we said was P divided by 2 pi. squared divided by p. Okay, so I set up an area to perimeter ratio, but I'm swapping out the s's and r's for an expression that has p in it. Now we need to simplify them. How do we square a fraction? Okay, so for the square here, we get p squared divided by 16. And the whole thing is divided by p. Dividing by p is the same as timesing by 1 over p. So p squared divided by 16 times 1 divided by p. Can we reduce out one of the p's? So we end up with p divided by 16. Okay. Over here, we've got pi times p squared divided by 4 pi squared, all divided by p. Dividing by p, we said, was the same as doing what? Multiplying by 1 over p? Okay, so can we reduce out one of the p's? And could we reduce out one of the pi's? So we end up with 1p divided by 4 and 1 of the pi's. What is 4 times pi, roughly? 12 something, right? 12 point something. So we are trying to compare these two ratios. It's an area to perimeter ratio. We've got perimeter divided by 16. We've got perimeter divided by about 12. Which one's going to be bigger? P divided by 4 pi is going to be bigger. So if we're comparing, p divided by 16 is smaller than p divided by 4 pi, which means that's going to be the better area to perimeter ratio. We're going to get more area for the same amount of perimeter. So making that playground a circle would be the best. Okay? All right, there is your assignment.